How you doing? Joe Collins. I think I saw Nicholas just earlier. Hope you all are doing fine.
Doing well.
Yeah,
How
we're
about you,
doing
Kevin?
fine.
Awesome, awesome, awesome. Yeah, great day today. Mm, sorry. Sorry, I'm taking coffee even though it's late. Okay, yeah, it's been a very long day for me though. All right, so yeah, I think I wanted to know if any of us here have actually been able to set up Linux machines, Linux VMs.
Yes.
All right, great, great. Sorry, let me just mute this.
Yes, I was having problems trying to create the hash file, but
Okay, just give me a second. Let me, because I'm joining two devices. I mute one. All right. Yeah. Okay. Sorry, Joe. You can go ahead.
yeah, I was having issues trying to create the hash file, and kind of forgot my password to log on to the Hello
Linux.
Linux. So yeah,
Ooh,
so
ooh, that's a problem. That's actually a problem, because
yes,
I'm sorry, but it means you might have to reset your Kali VM again. I always advise people to I always advise people to um, write down such passwords, especially
yeah,
since the password that is for test. Just
yeah.
advise people to write it down. So you might
I got
have to
a screenshot
do
of
it
it. I was
again.
looking for it on my computer. I couldn't find it anymore. So
Uh, so sorry. So sorry.
yeah,
I know you'll be quite stressed out because you have to start the process entirely. That can
yeah,
be pretty annoying. So sorry about that. But then I think since you've done it before, it shouldn't be as difficult
yeah,
as
yes.
yeah. So I think it should be quite it should be more straightforward this time, in my opinion. And it should be a bit more straightforward, in my opinion. Okay, so all right then. So aside Joe, who else has tried to set up the Kali VM?
I was able to set up mine as well.
Oh, nice, Collins. It's so yours is running at the moment, I assume.
Yes, yes.
Oh, beautiful. That's nice to hear. That's really nice to hear. Okay then. All right. So okay. So that's great. That's great. Um, okay, so meaning that have we been able to do some of those tasks like learning learning the simple commands, practicing simple commands and stuff like that. Have we been able to do that yet?
Yes.
Oh, great.
Yeah.
Oh,
It,
awesome, awesome,
pretty
awesome.
interesting though.
Yeah, that's great. That's great. That's what I like to hear. Yeah. So because I think this, if I'm not mistaken, this should be class 8. So it does peaks to
No,
7.
seven. I think that's
7.
seven.
Yeah. I think it should be class 7. So basically, I have about let me check. I have about 9. Um, so I have about majority to one after the day 3, 4. Okay, yeah, 5. So I have about 5 more classes, if I'm not mistaken. Yeah, about 5 more classes, if I'm not mistaken, with you guys. So yeah, because after today, I actually have got 5 more classes.
Will you be the same one teaching the advanced class, Kevin?
Yeah, yeah,
Okay.
yeah, most likely. Yeah. But I'll certainly verify with the team, but I most likely would be the one teaching the advanced class.
Okay.
Yeah. All right, awesome. So I'm actually getting really excited because right now we're getting to the stage where it begins to I use the word it begins to add up, right? Where all what we are saying begins to materialize. I know last week we discussed cryptography. I showed you a few things. I don't know if did we go through the Caesar cipher? Did I practicalize some examples using Caesar cipher? Did I do that? Did I also practicalize the visionary cipher for you guys last week? Trying to know if we went through that already.
Yeah, we talked about the Caesar cipher,
But we didn't show
and
it.
you no, but you
Okay.
did the hash too. You did the hash.
Okay, but I did the hash. Okay, but I didn't do the hash. Okay, yeah, good, good, cool, cool. All right then. So now what we would do here is we would actually perform. We would run. I like to do a few ciphers. So we would do work out the what's it called, the scissor cipher here. Mm-hmm. Work out the scissor cipher here. Let me try and get my platform up. Yeah, yeah, we got this. Also, I'm pretty sure we've already done intro to networking. I'm not sure if we did subnetting properly, but I'm just trying to look. What I'm trying to achieve right now is I'm trying to look for all the gaps, that we might not have talked about extensively, and I want us to really hit it extensively, as extensive as possible. Really, that's what I'm trying to achieve right now. Yeah. So I'm just going to go and pull it all up, and then we would begin. All right. So yes, so this is sharing my screen now. Just going to share the entire screen. Yeah, so before I begin, and start talking about things that I want to talk about, I I like hearing questions, especially when I find out that students have taken the initiative to ask some questions, do a bit of research on their own, task themselves on a few things. I like asking questions and say, oh, okay, you know what? So far, so good. Where are the confusions? What are the things that you would like a bit more information on? Probably you did something. Oh, what does this thing I did, what would actually look like? Those sort of things. I want us to discuss it before we begin. So, are there anything of that sort? Hmm? Anything of that sort? Okay, so I guess we're good to go. All right, so let's start with the Caesar cipher, right? Now I talked about it in the last class, but we didn't actually go through test anything on Caesar cipher. So the first thing we would touch on the Caesar cipher is so who can tell me the how the Caesar cipher works? because I know I talked about it last class. Who can tell me how it works? Um, Basically, how does it? Yeah, how? Yeah, I think that's the word. So, how does it work? Who can break it down for me? Yep. Anyone? Collins, Joe, Nabi, Nicholas, Adonye. Anyone? Okay, so that means we've all forgotten that I said that Caesar ciphers um, work as a breakdown in terms of another breakdown is shifts. That's a better word. Works as a shift. So, for example, um, okay, so let's put down because it's based off of the alphabet. All right. Now, I've put down the alphabet on this document. All right. Now, uh, okay. Now, let's say we wanted to encrypt or change or cipher. Um, let's pick a word off the top of my head. Uh, Diary. Right. Now, Caesar wants to send a message called diary to his soldiers who are fighting a war, right? He wants to send a message across to his general fighting a war. Now, he doesn't know exactly what's going wrong. He doesn't know exactly the issues, right? He just says, okay, you know what? I need to send this message to these guys fighting this war, all right? And yeah, he's sending it, and now basically now the issue is we're thinking really um, how do they understand the message? How do we encrypt the message for them to understand? Now, what's going to happen is we're going to move or shift. We're going to move or shift it. Okay? We're going to move or shift each letter. All right? So just give me a second. I need to write something down. Right. Okay, sorry. So now we're going to so Caesar cipher happens in a shift of three. In a shift of three. So for example, this is the first letter D. Now we move this by three. This is 1, 2, 3. That is G. Now what that means is the first letter is G. Right? Now we do the same thing for A. I move this by 3. A. If we move A by 3, that is B, C, D. Now this means that this is D. We do the same for R. Now, if we move this R by 3, 1, 2, and 3, means that's U, right? We do the same thing for E. So this is E, F, G, H. The fourth letter is H. And we do the last for Y. Now this is Y. Now this is where you now start knowing that. So it goes back to the beginning. So Z, A, B. And the last letter is B. Now, when Caesar sends his message, he doesn't send Gary as his message. He sends GDUHB as the message. Now, once he gets to his general who understands how the Caesar cipher works, me as a general, I'm looking at it and say, oh, the first letter, I in general, I'm saying, oh, you know what? The first letter is G, right? The first letter is G, right? Now, if I move back 3 times, that's from G. So 1, 2, 3, that's D. So I know this is a D. The next is D. If I move back 3 times, 1, 2, 3, that's an A. The next is U. If I move U 3 times, that's an R. The next is H. If I move H 3 times, 2, 3, that's an E. And then Y, sorry, and then B. If I move B backward 3 times, 1, 2, 3, that's a Y. I don't know if this is making some sense. So this is actually how it works, right? It's a shift for Caesar. It's a shift. We move from one place to the other, But then it's not very difficult. It's just like how you're using it. It's almost like using a weak encryption model, right? It's not very, very difficult. So what do? We use another model. There are other different type of cipher models, and another really popular cipher model that I like to use is one that I call the Virginia cipher. Right? It's a model that actually uses some form of image. Let me get the Virginia cipher image here. Let's see. No, let me come here and get it. So let's see. Yes, see, Virginia cipher table. This is a table. All right. Now this table, okay, this table is the trick. You got that? The table is the trick. So let me get it. Let me get it out. Okay, so trying to look for the one that we can use. See in action. Okay, trying to go like let's see if this one would allow me. Perfect, good. Now this is the Virginia cipher. Now the Virginia cipher is pretty unique. Now how it works is it works with a Virginia cipher table. Now if you look at the table, you see that it's a horizontal A to Z and a vertical A to Z, and then each inside is an A to Z running horizontally and vertically, and then completing to Z. So for example, so this starts A all the way to Z. Also, it also means this A goes all the way down to Z. But then this is, now if you come to here, this next one, it continues from this B, C, all the way to Z, C all the way to Z. It comes here, this now becomes E, all the way to Z, E all the way to Z, right? It comes here, G, all the way to Z, all the way to Z, I. So almost as if there is an A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. All right, you get it here. So the C, E, sorry. So C all the way to D, all the way to E. This becomes an E. Now this becomes an F because it's F that is following it. Now this becomes an I. This becomes a K. This becomes an M. This becomes an O, P, Q, R, S, T, U, V, W, X, Y, Z, then A and B. So if you look at it also, it almost seems as if there's a diagonal of each letter here. But the point is, this is how it works. And when Z stops, you start with A again, right? So this is just basically how the table works. Now, this table is what's used to perform the regional cipher. Now, um, now for this, there are two things that are important. You know, if you remember what I said in the last class, I said there are a few things that are important. There is the text, that's the plain text you want to encrypt. There is the cipher, which is the type of cipher that the plain text will go through. There is the key. The key is one that determines the result of that plain text after going through that cipher. And then we have the cipher text, which is the resultant text that will be sent across. So in regional cipher, it's still the same thing. You have the plain text. In this example, there is in the Michigan Technological University. We would use another. We would also use our diary, right? Now, the key is now what the time. Now, if for all we'll use our key, we call our key at 80. So what that means is, let me show you what that means in real sense. Let me go back to our document, right? So with regional cipher, we want to encrypt a word diary, and our key, said our key is at. But then if you see our key, normally what we try to do with the regional cipher is each letter in the plain text matches a key. So because the plain text is five letters, the key is just two. In fact, sometimes the plain text can be a phrase, a sentence, and the key might just be a 5-letter, 4-letter word. So you just need to redo it. So just the same way as when A ends, you go and start again. When it starts at Z, you start at A again. The same thing. So we do AT until every letter in the plain text has a corresponding letter on the key. Does this make sense so far? I need to be sure that we are all with me, like we're following. Guys, are we here?
Yes, yes.
All right. Thank you. Thanks, guys.
Hello.
So,
Sorry.
yes, please.
Are you saying that that 5 letters you do 80 into 5 places? Is that what you're saying?
Exactly. So if you see,
All right.
we did 80, A. It stops as A till the
No
letter is
problem.
complete. Exactly.
All right.
Good. So now, when we now do this, so now what happens is we then use the table. Now, this is where the table comes into play. Now, you should note that the what's it called? The horizontal, that's this one here. The horizontal represents the actual plain text. That's what we actually encrypting. The vertical represents the key itself. So if we take that into consideration and say, okay, here, this is our plain text.
Sorry.
Yes, please
Sorry,
ask
sir.
question.
Sorry. Let me take you back. If
No
if
problem.
we did that thing we are just now, it will not stop at A now. Because I
What do
wrote
you
it
mean?
down. The D will have 80. A will
No,
have
no, no,
80.
no, 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 no. Okay, so you might have misunderstood me. I mean, not 80. So each letter has a corresponding letter in the key, not a
Okay.
corresponding key in total.
Okay.
Yeah,
Okay. A corresponding letter in the
exactly.
key. So that is all right. A. The next letter will be T, and that letter will be
Exactly.
A. The next letter will be
Exactly.
okay.
Exactly.
All right.
That's why it's this way. If you see D is to A is to T, R is to A, E is to T, Y is to A.
Okay.
That's how it works.
Okay. Mm.
All right then. So now, so with that in question, now we can now go back. So
You can go.
let's
You can go.
yeah, all right, thank you. So now if we use that, so the first thing is, as I said, horizontal is the message, plain text, vertical is the key. So the first letter in the plain text is D, and the first letter in the key is A. So that stays D. That doesn't change. All right. So we'll keep it. I'm also writing mine down somewhere. Right. That doesn't change. So we keep that. Now for the second one, to D A E T R E Y. So I'm also trying to write mine down as well. Okay. So the first letter D to A stays D. Now the next letter is A. A is to T. Now we'll go straight down till we see T and we stop. And it's actually T. All right? So A is to T. The resultant is T. So it's T. Right? Now the next one is R. R is to A. So we go R is to A, which is R. That doesn't change. Now E is to T is the next one. Now this is E. And we go straight down till we see T. Now this is T. Where the vertical is T is what we're looking for. So that's X. That's X. Right? Then the last is Y is to A. Now Y is to A is obviously going to be Y. So it should be DTRXY. So the resulting should be DTRXY. DTRXY. All right. Now, imagine we were given this DTRXY and told us to decrypt it. So we get sent this DTRXY as a message and say, oh, this is a message sent to you from Kevin, who is working with the US Navy, and he used the Virginia cipher to encrypt it, and he wants you, this is a secret message, and he wants you to work on, and he encrypted with the Virginia cipher, and his key is at 80. What do? We do the same thing, right? We do the same thing. We come, populate the key around it, 80, 80, 80. Now, we would then do a reverse check. What do I mean by reverse check? Remember, vertical is the key. This horizontal is the plain text. So to get to the plain text, we look at the key, and on the horizontal line of the key, we look for the cipher text result. So the first cipher text is D. D. So the first cipher text is D. The first key, sorry, is A. So this is A. With the first cipher text D. So we look for D anywhere on A line. So this is it. So come up D. So the first plain text becomes a D. The second cipher text is a T. Let's look for T. And then the second second key is a T. Second cipher text is also a T. So T to T. So CT. T is right here. T is right here. So that's A. Second key is A. Cipher text is R. If we look for R, we see that the text is R. Next key is a T. And the cipher text there is X. So let's look for X, 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 C, X. So that's an E. And the same thing, next key is an A. The cipher text was a Y. So Y. And we get it back. Pretty straightforward. Now, this is a very easy one to do. Let's try and do something a bit more difficult. So someone should give me a word that's about 7 letters. A random word that's about 7 letters. Anybody?
Moloni.
Moloni.
Moloni. Yes.
Spell, sorry. Let me know if it's the same Moloni.
Moloney.
Oh, Moloni. Yeah. Okay. Okay. That's good. That's good. So someone else give me a key. Someone else give me a key.
Let me give you a key.
Yeah. But the key is nothing more than 3-letter word, but without that doesn't have an A inside it. I don't want it to have an A inside it.
You don't want it to have an A.
Yeah, I don't want the key to contain an A.
Okay. Leap.
LIT, leap. LIT.
LIP. Yes.
Oh, P, leap. Okay. Right.
Leap.
So leap.
LIP.
All right. So obviously we would have to put this to Okay, so M to L, O to I, L to P, O to L, N to I, E to P, Y to L. Yeah, this looks good. This looks fine. Okay, now let's work around this. Let's do something around this. All right. Okay. So um let's move. Okay, so we go in here and we begin to break it down. Right. So firstly, this is our key. This is our plain text. Now the first plain text is an M, and the first key is an L. Right. So go M.
Yes.
All the way till we see an L. I think this is it, if I'm not mistaken. Yeah, I have to actually go there. Yeah, that's it. An L. That is
That why
X. X.
X.
X. So X is the first cipher. And the next is O. So an I. O to an I. This is O. O to an I. Actually use my hand. So that's a W. It's a W. It's a W. Let me zoom a bit closer. Let me zoom this a bit so
Yes.
that you guys see it better. Yeah, I think this is better now. Yeah. So the next is an L to a P. An L to a P. So this is L. And let's look for P. L.
Take it up a little bit. Okay.
Yeah, let's look for P. Let's look for P and L. P and L. I think that's A. I think that's A. Yeah, that looks like A. A.
That's A.
A.
O,
All right. Now let's do the next one. The next is so O to an L is the next one. O to an L. Okay, so O to an L is O to an L is Z. Z. Thank you. Z. So now next is N to I. N to I. N I.
V.
That's V, right? Thank you, V. All right. How about E to P? E to P.
That's T.
T. Thank you. Thank you. Then Y to L. Y to
J.
L. J. Thank you.
J.
So ciphertext, what I'm seeing is X. So what I'm seeing is I'm seeing X, W, A, Z, V, T, J. This is our ciphertext. This is so not Moloni. Now, if we're told to convert this using the key leap, right? So yeah, we're told to convert this. This is the ciphertext now. Convert the ciphertext to plain text using the key leap. Right? After we've sent this message, sent it to someone, now send the person to convert it back. All right? Now, what do? We begin. Right? So let's go. So the first is, so let me do this. So it's going to be L, I, P, L, I, P, and L. All right, back to the plain text. So let's do this.
I think you should plug your laptop. We still have 1 hour more to go.
Oh, thank you. Thank you. Thanks for bringing my attention. Yeah. Yeah. Thanks. All right. So now, if we do the same thing, we would see X to L. So now, X is the ciphertext. So now we'll go from the key. You understand? Now we'll be going from the angle of the key, not the angle of the plain text now. We're looking at it from the angle of the key. So what we'll be saying is, oh, okay, key is L. This is the key, L, right? What is it's L to, the ciphertext from L is X. All right, so let's look for X. L, we're looking for anything that's X on L. This is also X. You see it here? What does that? What's that? If you go up horizontally, that's M. That's M. Pretty straightforward, right? We can do the same thing. You do W. I'm sorry, I. The key is I. So I is to W. So we go through I to find our W and we stop. See W. That's O. Now we go to P. P is to A. So this is P. We go through P to find an A and see it here. That's L. L. Now the next is L to Z. L to Z. So we go to L and look for Z.
That's O.
L.
That's O.
That's O. Thank you. Now I to V. You go to I and go through to find V and see V. V is N.
N. Yeah.
Exactly. N. Now, next is P to T. Now we go to P and look through P to see T. This is T. E. And the last is L to J. So we go to L and go through L to see J. We see J. That's Y. And we have Maloney again, which is what we expect to have. Does it make sense? Does it make sense?
Yes,
Awesome.
it does.
Awesome. Good. So now this is the cipher concept. The cipher concept. So the cipher concept, this is it. So so this is, as I said, it is what I like to say is it's not like in the real world, in the digital world, in actual encryption of digital devices or digital data or information. This is how it works. These ciphers are the precursor to encryption. That's what I'd like to explain. These are the things that brought up the concept of encryption. And then we started putting a lot more levels and types of encryption. For example, I know in our last class last week, I showed us the difference between DES and triple DES. The DES was maybe 64 bit, this bit, maybe 5 rounds of encryption. Triple DES was triple of whatever I did in DES. So meaning that for you to encrypt something using the triple DES algorithm, it's a certain bit of encryption, that the encryption keys are certain bits, the ciphertext are certain bits. Then also the amount of time, when they say round of encryption, that is the amount of time something is encrypted. For example, if we use this our example, right? And round of encryption. Okay, so this is, this ciphertext here is one round of encryption using the Virginia cipher and leap ASCII. Meaning we could actually encrypt this thing again, where XWAZVTJ is actually the plain text and not the key, and not the ciphertext. Actually, I've not done multiple round of encryption using Virginia cipher before. I want to know if it's not meant to give us the plain text, but let's try it. Now, let's say we take this Moloni on 2 rounds of encryption. So meaning it will go through encryption again. So let's do it. So the first round gave us XWAZVTJ. Second round, we're about to find out what it will give us. So if we do that way, go to the second round. Go to the second round. All right, so this is second round. X is the plain text this time on L. So this is X on L. This is L here. Yeah, this is I. So it gives us an I. All right. I hope you guys are with me. I hope you guys are not confused. I hope you're not confused. Yes, Claire.
I know I'm late, but I'm confused.
Okay, so is it the encryption process or is it the multiple rounds of encryption that's the confusion?
Is the I understand the last one or the Maloney,
Okay.
but the double, what did you call it now? Multiple round of
second round. Okay. So what I'm saying is there are some encryption algorithms where you would say that there will be maybe 10 rounds of encryption is being done. Now, rounds of encryption means I encrypt you once, right? And I get, as I said, when you perform encrypt a text, a plain text, your result is a ciphertext, right? You can encrypt that ciphertext again. So I encrypt you once. So for example, using this Amoloni as example, we encrypted Amoloni once using leap as the key on Virginia cipher. We got XWAZ VTJ, X was VTJ, if you want to pronounce it, right? And now we can encrypt this X was VTJ again using leap as key. That is the second round of encryption, where X was VTJ is our plain text, not our ciphertext. That's what it means by multiple round of encryption. Encrypting it again. That's what you've already encrypted with the actual ciphertext goes through another round of encryption. And that's what I'm trying to do now.
Okay, so that means that the Maloney is the first answer. Then the second round of encryption is the
X was.
X was. So you're going to encrypt X was again, but won't that give you Maloney back again?
No.
Why do you have to do that all over again?
It won't give you Maloney back again. It would not give you Maloney back again. That's one thing I'm sure of. And also, why we are doing it again is to make it much more difficult to crack. Make it difficult for someone to break it. That's the idea of having multiple rounds of encryption. It's just like making it a stronger encryption.
I see. Okay. Thank you.
All right. Pleasure. All right. So moving on. So as I said, we are on the X was which. So we've done X. Now let's do for W. W where the key is I. So this is W, and we go down. So this is I here. This is I here. Is that I? Yes, this is E, right? Thank you. E.
Yeah.
Now we do same for A is A to P, I think A to P is P.
That's P. Yeah.
Then Z to L, Z to L,
That's K.
okay, right?
K.
Awesome. Then V to I, that's D.
V to V to I.
That should be D if
That's
I'm not
D.
mistaken.
That's
That's
D.
D, yeah, exactly. Then T to P. T to
That's
P.
I.
I, awesome. Then J to L,
That's U.
U. Now, the second round of encryption would give us, the second round of encryption will give us
Hold on, please. That J to L, please, can you check that again? I don't think it's you.
J to L. Let's see. J to L. This is J. Is U.
Oh, okay. Okay, thank you.
Okay. So, so this gives us I E P K D I U.
Wow.
This is second round of encryption. And we can keep going and going and going. There are some encryption, there are some algorithms that have 10 rounds of encryption. Yeah, they exist. So those rounds of encryption makes it a much more difficult encryption to crack. It doesn't make sense. You get that? So yeah, that's the way it works. That's the idea behind it. And as I said, ciphers are the precursors to encryption algorithm. They are not necessarily the encryption algorithm that are being used today for you and I. Now, let me see if I can show you an example of an encryption algorithm. Now, one of them can be used through Kali Linux. All right. But any questions so far before we jump from this? Now, another thing I didn't mention is for ease and speed, we can actually use what is it called? A platform called Decode. We can actually use Decode. Now, Decode is a platform for encryption and decryption on ciphers, for ciphers though. So we can actually go in, look for a certain cipher of our choice. See it here, see the Virginia cipher. There are a lot of ciphers out there. So see the Virginia cipher. And then let's prove or show everything we've been talking about since. So we did Moloney, right? Moloney. I think this is double M. And English, please. No, not yet. Oh. Okay, send us to decrypt. This is a decryption. No, so encrypt Moloney. Encrypt it. Our key is what? Leap. Now let's encrypt it. See our result. Is it the same? Is it what we got? See here. Is this what we got? X, Y, Z. Isn't that the case?
So I want to find out.
Yeah.
Okay, I want to find out, please. What's the meaning of leap?
Well, leap is the key.
Okay.
Yeah, leap is the key. The guy
So
that we are using.
every cipher must have a key.
Oh, yes.
Oh, I see.
So not every encryption must have a key. So I need to point out that it's not that all Virginia cipher, the key is leap. The key can be anything. Anything the person encrypting chooses. That's why encryption is difficult. For example, if I encrypt your file and you don't have the key, that file is gone. That's the concept behind ransomware attack, where I will encrypt your files, you are unable to use your file and your systems, and then I'll tell you to pay a certain amount of money for me to give you the key to decrypt it.
Please come again.
What'd you say?
I said, please come again.
Okay, so I'm
Like,
saying that it doesn't matter the cipher or the plain text. The key is not permanent. The key is based off of me. And that is the reason why, that is the concept behind ransomware attack. Because if I don't give you my key, most times you will be unable to decrypt it unless it's not a very strong encryption method. Do you understand? So it's not like all keys must be leap. No, that's not the case. Do you get where I'm coming from? All keys must not be leap.
okay.
Exactly.
Okay.
Good. Yeah, perfect. So moving on. So now I was saying that on this platform, we can actually go back and decrypt this. Let's decrypt this and use a key. Use our key leap and decipher this. You can see it, Moloni is back. But we can also use this. Let's encrypt this again for the second level of encryption and see what happens. Isn't this what we got as a second level? IEPKDIU. IEPKDIU. Exactly the same thing. Now, if we go and decrypt this IEPK, right, we will get what? X watts. See it. I'm just using this automated method. I'm just using this automated method to show what we've been doing all along and show, let it be like way of proving it. All right. Great. So I just thought I should show this. And I think we can move to, we can then move to, yeah, we can move to the one on the Linux box, right? I said I wanted to show us how the one on the Linux box works. So I'm going to share my other screen. You'll bear with me because my Linux box actually failed. So the one I'm using is a temporary system, not as fast, certainly not as fast, but should still be able to do the work, hopefully. Hopefully, should be able to do the work. Yeah. Okay, so this, let me log in. Okay, so here we are. Now, as I said that there are some Linux or there are some encryption models out there. All right. Now, some of them are things like maybe let's say there are concepts like GPG or PGP. Right now, one that can be used on Linux is the GPG. Now, to use GPG on Linux, you run a command. I really don't know how to maximize any further than this. So you're going to have to bear with me and probably maybe maximize it on your own window for you to see what I'm saying, for you to see what I'm typing clearly, a bit more clearly, right? But this is the most I can maximize it right now. So I'm saying we can do this first of all by installing GPG itself. So in sudo install GPG. Let's see. Sorry. apt install. Yes. So the command is sudo apt install GPG. So the installation is currently running. Now, what we're trying to do is GPG is a framework or a tool that we can use to actually perform encryption, right? You can use it to actually perform encryption on our Linux machine. So it's telling that there's some services installed on your system which need to be restarted when certain libraries such as libpam created since this. So just say yes. Yes. Right? Let's see. So it's currently installing. Okay.
No coffee today.
Yeah, I have actually just taken my last. Just my last in the laundry. All right. So as you can see, it just finished installing. Right? So now we've installed the GPG. GPG actually stands for GNU Privacy Guard, in case I didn't mention that. GNU Privacy Guard. It's a sort of open source framework, all right, that you can use for encryption on your Kali Linux. And so I've done the installation right now. That's what I just installed. Now I'm going to now, after this, I'm going to now generate the key. Now to generate the key, I'm going to use the command gpg dash dash full dash generate dash key and click enter. Now, once I do this, it's going to show me some instructions. So it showed me the GNU, see it now, GNU Privacy Guard, GNU PG, the version, copyright, told me this is a free software, no warranty, and a lot of information. Now it asks, what kind of key do you want? RSA, which is the default, RSA, DSA, L, Gamal. These are all different types of encryption algorithms. All right. Now I would pick the first one, which is one, RSA, which is the default, which is fine. They'll ask me, what key size do you want? I always advise people to use the 3072 key size, which is the highest that shows you there, the recommended one. So just type in 3072, press enter. Then it says, please, it now says, please specify how long the key should be valid. Meaning, how long this key you're generating, how long is it going to be valid? Now, remember, before, you don't have to say, oh, this is the way, this is the key I want. You don't have to determine and say, this is the key that I want. We make that decision before in the past, right? In the cipher model. Now, on the digital model, we generate the key based off of the technology or the tool we are using. So based off of the technology tool we are using right now, we're going to generate the key. All right. Now, so we are this the key we are generating. So the tool has asked us, do we want this key to expire? If we put a 0, the key does not expire, but that's not the right security mode. The right mode is to put a timeline. The key should be valid for a certain amount of time. And so we need to define that as well. So we put it, so let's say the key expires in, so if we put only days, if you put whatever, if you just put a number, it will be expired. Let's say if you put 5 or 10 or 20, according to what you're seeing here, it will be expired in, let's say, 20 days. If we put 20W, maybe we are telling it to expire in 20 weeks. If we put 20M, maybe expire in 20 months. If we put 20Y, expire 20 years. I don't want it that long, so we'll do 1 week, right? Let's do 1 week. Oh no, let's do 2 weeks. Let's do 2 weeks. 2 weeks. 2 weeks. So 2W, right? Enter. You can see the timeline. Today is, what's today's date? Today's date is the 22nd. Oh, I meant to get myself today. It's the 22nd of June. Now, 2 weeks from now is the 6th of July. It asks us, is it correct? I would say yes, it is. Now, GNUPG attaches a key, attaches the key and encryption to something, to a user ID. So we have to give it some details that it uses to register and record this key. So let's give a name. So I'll put my name, right? I'll put my email address. Right? Any comments? Kevin, Ray, Key, right? That's the comment I chose to put. And now, we're good. Now, if everything is fine, we just put in O and enter. Now, this is also another thing that makes it awesome. Now, the key is one thing. Passphrase is another thing. The passphrase is a way for it to verify that you have access to the key. It's like a password to access the key or to use the key. That's what the passphrase is. They have to put in a passphrase. Now I'm going to put in a passphrase that I can remember. I will put in one that I use a lot. So I have typed in so I wouldn't forget it. So please, if you're doing this, I also advise you to write it down. I have my passphrase already written down. So I'm not going to do anything too difficult. All
I
right.
have a question.
Yes, go ahead, please. Oh, yes, Claire. I can see your hand up.
You mentioned that the pass key,
Phrase.
password key, that means it's like a password to access the password.
Kind of. To use the
Okay.
password, kind of. Okay, so let me explain. The key, I really don't like looking at the key like a password because the key is used to, it's so, I don't want to call it a password because the key encrypts, you use the key to encrypt and decrypt that file or the document or whatever it is you want to encrypt, most likely a file or document, right? So the content of the file or document will be unreadable unless you use the key to either decrypt or encrypt it. So it is kind of like a password to a password, but I don't want to see it like a password to a password. I want to say it's a password to use the key, which is what is required to decrypt the file. Now, I also like to let us understand that. So before I go ahead, Claire, did I answer that question? It is kind of that, but I don't like looking at it that way. All right. Thank you. Collins, your hands are up.
Okay, sorry, please, I don't know if you have gone over it. I want to know what's the use case of this PG, and can I run it on my Windows terminal as well? As in to
No,
install GPG on my Windows
Linux,
terminal.
Linux terminal.
Okay,
See you
so
next time.
please, what's the use case? How can we?
Okay, so the use case is encryption, cryptography, encryption. That's the use case. Encrypting your files. So you want to send the file and you only want you and someone else to understand. So you create a key, use it to encrypt your file, which we will do here, and send it to whoever you want to send it to. Now you give the person the key separately or secretly, and only the person can access your file. That's it.
Okay. So in essence, we just enforce integrity and confidentiality.
Exactly to enforce confidentiality and integrity. Yes, especially confidentiality in this case.
Okay. Thank you.
All right, you're welcome. Adonye, your hand is up.
Yeah, yes, sir. From what you're explaining, I'm thinking
Yeah.
this is looking like what the banks do when they send you your statement of account. So the only way you can open it is by using your
Account
account
number.
number. That same
Um,
thing.
no, it's not. Reason why I said it's not is because that account number is just basically telling you is a password, right? They're just basically giving you a password, and it's not even a secret password because anybody that has your account number means they can open the same account. So it's not really the same thing. Okay, you know what? Okay, no. So what it is, yes, not the same thing. It's just basically like if you're passwording a file, not encrypting a file. I'll show you what it looks like when you encrypt the file, when we do an encryption here. Hmm? Is that fine?
Yes.
Right. Okay. Okay, so I think I can go on. Right. So now you can see that this has been created. This here, you see this thing here? This is our public key. So now, you know, I taught during our last class, I mentioned the different types of algorithm. We said there's symmetric and asymmetric. Asymmetric is the one that has both public and private, if you recall very well. Now, the asymmetric public and private means that the public is used to encrypt, private can decrypt. Do you get that? Now, the kind of algorithm we ran here and the kind of key we did here is for asymmetric, the ones with private and public. So that's why I can see that there is a private key, public key here. That's the concept behind it. However, for GPG, I think the keys are kind of like the same, like public and private key. I think they are kind of the same. But then there is one that is registered as public, one is registered as private. Okay, so for example, I can start by listing the keys. So if I wanted to check all the keys that we have, let me start by clearing. Let me check all the keys we have. So I can say GPG dash dash list dash public dash keys. Okay, so I can see this. These are the public keys. See it here. This is the only public key we have created on GPG. And see the user details. You see my name, you see my email, you see my comment. As I said, it recognizes each key based on their user identification. How does it identify you? Now we can also do the same for secret keys, that is for the private keys. Right? So if we press enter, you can see our secret key. See it here. All right, so that's what this is. So you can see our secret key. Now, if you notice what I was telling you, that they kind of look alike, both secret and private. They kind of look alike here and here. They actually kind of look alike. Right? So yeah, that's how it is. That's how it works. So let's see. So yeah, so that's the how to check the keys. Now we can then export. We can then export our key, meaning bring it out as a file of its own. Because right now it's here, but it's not. We can export it from GPG, making it a file of its own. So to do that, we can just run this command saying GPG dash dash output pub e dot GPG dash dash export. I don't know if there's going to be anything. Let me see. Oof, yes, it has worked. Now we should find a key named GPG. Oh, I didn't even check my current working directory though. Backtrack, okay. You can see it here. This is the key. We have exported it out of GPG as a file of its own. We can even check the content of this key. This is it here. You can even see that the public key is even encrypted. The exported file we exported is encrypted. You can see that. This is what it looks like to be encrypted. You can't even see it in plain text. Do you get
I have a
it?
question.
Yes, Claire. Yes, Claire.
Okay. It looks like this is more or less like a coding. Do we have to run this? Do you have to write the code ourselves? Because I understand you have the dash 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 and all that. It's more or less like you're running a code. Is this something that we also will have to run, like what you're doing?
Let me put it this way. First of all, I'll correct you and say that it's not coding. This is commands. Yes, it is languages, but they are commands that can be learned and can be written down. And as a lot of people in cybersecurity will tell you, you can't remember every command on your own unless you do it day in, day out. Yeah, sometimes you still have to Google for some commands and check. There are commands that can be accessible and should be used by everybody. Now, do you have to learn it? You do not have to learn it. But it's an added advantage understanding how encryption works, understanding how to perform encryption on Linux environments. It's an added advantage. You might need to do an encryption one day and then you'll be asked for to perform a simple encryption task to just encrypt a small file before it's sent across. Something as simple as that. Does that make sense?
Yes, it does.
Awesome.
So
I don't
we're
need. Okay,
learning programming
Claire, go ahead.
command languages, more or less like programming.
So that's what I'm saying. We are not learning programming. These commands are not programming languages. These are
Okay.
not programming languages, exactly. These are
Okay.
languages for Linux. Remember when we did that Linux command introduction and we said Linux commands and all? That's
Yes.
what this is. These are still commands on the Linux.
Okay.
Exactly. Adonye,
Yes, sir. Sorry, I just want to clarify before we go to this stage. When you type that stuff for the public key and the secret key, the key you pointed, you said they were different, but when I looked at them closely, what you pointed were the same.
no, that's I said they were the same. I said it. I
Okay.
said that. Yeah, I said that. So normally they are meant to be separate keys, public and private, but the GPG model would give you the
Mm,
same keys for public and private. It's the
okay.
technology and the framework you're using
Okay.
that made it the same.
Okay.
It's
Okay.
something I
Thank
also
you.
noticed myself. All right, thank you. Awesome. So now we could as well import a key. The same way we exported the key, we can as well import it. EUBKEY. And we imported it, but nothing has changed. Now this is if, for example, someone else has created a key, exported the key, sent the key to you, saying, "Oh, Kevin, you need to use this key to decrypt a file." This is how you can import it. So export the key, send that key to me. The other person imports it on his own GPG, and he uses it to decrypt that file we encrypt. But let's first of all even see how to encrypt that file. Okay, so let's see. What's this? Okay, sorry, I'm looking for where to encrypt my file. Okay, so there's a command, just cpg help. Anytime helpfulness, yeah, I've gotten it. So let me just look for the command for to use an encrypted file. Signature, clear text, signature, just sign, encrypt data. Yeah. Aha. Yeah, dash encrypt. It's happening. Yeah, I've seen what I'm looking for. Okay, so let's do. Let's run the dash encrypt. I'm just trying to see if there are any other conditions for that. Okay. Sorry, just give me a second to verify the command. Okay, yeah. All right, so gpg dash encrypt. Oh, sorry, I have to create a file first. Yeah, my bad. So let's see, touch. Let's create a file named test.txt. Right? Yes. So now, meaning that the file test.txt exists here. All right. So now let's encrypt. Okay, so let's edit the file. Test dot txt. Oh, why does this keep coming up? Xt. So this is weird now. Okay, so new file created. I'm just trying to put content in the file. You get, guys. So let's do that. Let's do this. Okay. All right. So now if I do this, I'll see that the file has context, has content. See it. New file created that. All right. So now let's now say gpg dash encrypt tst.txt. Now doing such, we need to enter. Oh, okay. I think I might have used the wrong command. Where is it? Okay, so yeah, so let me run it here. So it's GPG dash encrypt dash R. Um, enter the user ID. So put the email address that you use and into gmail.com. And I think I need to put the output. So test.gpg. That's encrypted. So let's see. Yep. Yeah, this has been encrypted. Now, if we check the file name ls, hmm, something is wrong. I'm looking for, yeah, I'm looking for the file I just did. Now, let me see now. Let me see if this works again. Yeah, so it didn't encrypt it. Didn't encrypt it. I think this is a problem. But Gmail. Sorry for the silence. I'm just trying to verify this. Then this encrypt. Then the file name. Okay, this is coming up a lot. Test dot. I press on test dot txt. Oh yeah. Sorry. This is dash O. Aha, I think this should work now. Let's see. Yes. Now I have a st.gpg file. Beautiful. All right. So yeah, I figured it out. All right. So this is it. Right. So what we did was, you see this command here. We told, so this command here. We use GPG to encrypt this file we created, test.txt. All right. Now, but then for it to encrypt, we have to let GPG know the key we are using to encrypt. So we encrypted this file text.txt using the user ID Kevin Pio Ani to, that's my email. So meaning that the key attached to this email, to this user ID, is what is used to encrypt this file. And then this is to say the output of the encrypted file is this. So now, for example, if if we want to, let's see, if we wanted to um, send an encrypted file, this is what we send. We send this, what we would send, let's say we wanted to send a mail, we send the mail to, let's say I wanted to, I know I need to send this to someone. So I will send this to Sorry, let me just open an anonymous email and send across just real quick. So I will say anonymous email. No time to start logging in. So I'll use this. No time to start logging in, so I'll just use this guy. Yeah. So let me just send it to myself. Yeah, right. I hope it comes in though. Once I touch a file. Oh, come on now. Let's do about that. I just touch a file. No, this is not. I don't have time to that. I can't remember the guys. So I'm trying to send an anonymous email, but I don't really think I have the time. So let me just log into my Gmail and send it. So while I'm trying to show you how it would work, that's not a way to send it across. So let me send it to myself. Right, and I will just quickly, sorry, just don't have to change. Let me sign in. Right now, once I'm done with that, I want to show you what it looks like actually, like in real life sense, what exactly we are using this file for. Now, because I don't want any other person to have or see it, I would send an email to myself. I send to my other self test and attach a file. Yeah, nope, just go home. Yeah, so this is an encrypted file. You can see the type of file, PGP, right? My encrypted message header. And then this is the key. So I can send these two. I can send the two of them across. Now, what that means is, let me stop sharing here. Yes, stop sharing this. Yes, so let me. Okay, so let me show you what I just. Let me show you what I just saw. So open my email here, all right, and show you what I just saw. So you get it. Okay, just send this right now. Right. So this is taking so much time to load. Hey, I just want you to see the file. Yeah. Just want you to see the file. Yeah. So look at it. This is the file. This is the file. This is the file. This is the file. So if I open this, I should download it. Add. Yeah. So if I open this, let me see. Let me show you what I'm talking about. I'm going to my downloads. You can see it can't open. It can't even open. Can't even open, even if I wanted to. Okay, I want to show you guys what it means. It's not even open. Aha, see it. You can see this is exactly what you did. You created a file that's unreadable. This message I want to pass across. Created a file that is completely unreadable. So it's an encrypted file. I can't do anything with it. Nobody can. That's the value. That's exactly what you were trying to achieve. What we did, this is what we're trying to achieve. I don't know if it makes some sense. Do you get it? Hmm?
I create a file that is unreadable in the first place.
Oh, so a file unreadable, it is encryption, but that's what we're trying to achieve. So that only those with the key can read it. That is, only those that have this file as well as this key. So normally we would send this across to them. Now, this receiver is meant to be a Linux machine. They would use the Linux machine. They will first of all import this guy, then use this guy to decrypt this guy. Do you get it?
I understand that we created the key and also we created a pass key. Is it? Wasn't it sent? It wasn't sent to your email because you don't have the permission. You
No,
now
no,
have to use the Linux
no.
to
Understand this.
decrypt it.
No. Understand this. The reason we are using Linux to decrypt it is Linux has the tool which we use to create this encrypted file. This which is the GPG. We don't have it on Mac. Or at least I've not tried to set it up on Mac. Do you understand? Let me see.
I'm almost there, but
Okay.
my question is, you created a, let me say, an encryption and decryption key, as well as a password to access the encryption key.
Yes. A passphrase to access it on my original machine.
Yes. And you did not send it to yourself?
No, I didn't. I don't need to send the passphrase. Do you understand me?
Why? Why?
Okay. So wait, let me understand the question first of all. You're saying, is the problem the passphrase or the key?
The problem is why you created the passkey, you created the decryption key,
Yeah.
and the encryption key,
Yeah.
and then you also created a passkey
Yeah.
for this file,
Yeah. Okay.
So, and then when you send it to your email address, it became, to open it, we realized that it was unreadable. Now, my question is, why was the key not sent as well with the file?
Okay. Oh, so the key was sent as well. This is the key here. Just the passphrase that wasn't sent. This is the key. We sent the key.
So how come it's unreadable?
No, so that's it. So for you to read it, you have to decrypt the file.
Oh,
She gets it now.
I actually thought the key, creating the command for the key is actually what will help to decrypt the file.
Okay, no. So let's go over it again, right? We have a key. We have a file. We have an
Yes.
encryption method, which is the GPG is what we are using to do the encryption. With the
Yes.
GPG, we generate a key. With
Yes.
that key, we encrypt the file.
Yes.
We then have an encrypted file.
Yes.
Good.
Which should be
Now,
readable.
no, encrypted file shouldn't be readable.
Oh, okay.
An encrypted
Not
file is not meant to be readable.
readable.
Yeah,
Oh,
the idea of an
okay.
encrypted file is only those with the key should be able to read it.
Oh, I see.
Exactly.
Okay. But you've
Now,
created a key for it, right?
come again.
I said you created a key for it. Yeah.
We needed the key to encrypt it in the first place. So obviously there's a key.
Okay.
Yes, which is this pub key you're looking at. So now what we did was when we created the key, we exported it because the idea is we will want to send the key as well as the encrypted file to our receiver
Okay.
in hopes with the idea that if our receiver receives it, he should use his own GPG to
Oh,
decrypt and read that file.
oh, okay. So not the key, not our own key. He will use
He
his
would
own
use
GPG. He will create
he
his own.
no, he would use his own GPG and the key we send to him, this key. Let me
Okay.
replicate it. Let me replicate it on on the Linux again, so you get to make it make sense. I'll replicate it again on the Linux. What I will do this time is I will completely delete the key that we have running. I'll delete the key we have running. So yeah, so this is Linux. Yeah. Okay. So the file we created, the original file we created is text.txt. So let's remove it. Test.txt. Let's remove it. So now we only have the encrypted key here. Now what we do is we first of all import that key. So meaning that let's imagine we were sent this pub key.gpg and test.gpg, right? We will now first of all import that key. Import pub key.gpg. Let me see if I can assign it to another user. Okay, let me just import it first. We have imported it to this. Let's even try and import it to another user. Let's see. Let's see. Science. Yes, Adoni, your hand is up.
Just wanted to see in line what you're explaining. The way I'm trying to put it together, the way you're saying, is this key, this encryption you're doing with the
Yeah,
GPG,
yeah.
is can I understand like something like, let's assume the passphrase is the key to my room, and the key, the encryption key you have already provided with from the GPG is the key to the safe in my room. So when I get the pass key, I open my room, then I'll now use the encryption key that you have sent to me to open the safe, which will now decode the content of the file.
Please come again.
Let from what you are saying, you said
Mm-hmm.
you're going to do, when you encrypt the file,
Mm-hmm.
it's going to produce, you're also going to produce the passkey.
Yeah.
Fine. So, but you also have a phrase, pass, or something like passphrase or something like that you
Yeah.
created too.
Yeah.
So the passphrase, from my understanding, now the passphrase is like the key to my room. That when I open the room, then I'll now go to where I have a safe, which is the encrypted file. Then I will now use the key for the encryption that you sent to open the safe. Is that what it looks like?
Well, your analogy does work. Okay, so let me try and break it down even further. Okay, so let me put it this way. You need to understand the reason for the passphrase. The passphrase is more or less like the guide that allows you, okay, test the key. Okay, let me put it this way. Mm, um, okay, okay, yes, let's use your analogy actually, Ahana. Sorry, Adonye, sorry. Let's use your analogy. The analogy is saying the passphrase allows you enter into the room, then the key allows you enter into the safe. Yes, that analogy can fly. That analogy can fly, but I feel it confuse a lot of people. But that analogy can actually fly because basically the passphrase is for the key. The passphrase's focus is while using the key, it's verifying. So the passphrase. Okay, let me put it this way. Um, you were hired for a job and you were given a certain code to be able to access the building to do the work, right?
Yes.
Now, exactly. You were given a code to enter into the building to do the work. However, when you enter into the building, right, there are some unique tools, some unique um, so the work you are doing requires a key to start an engine. You understand? Which is in your pocket.
Yes.
So that key to start the
Yes.
engine was given to you as the skilled person hold the key to start the engine. However, for you to enter into the building to do the work, a passcode was given to you.
Yes.
So what I'm saying is the passphrase is attached to the user ID. If you notice, if you see GPG, we had to add a user ID for the key we were generating. So the
Yes.
passphrase is attached to that user ID. In fact, one user ID, we can add multiple keys to it. So that passphrase is attached to that user ID. You understand me? And that user ID
Yes.
has a key he would use. So it's like a way of verifying the user ID that is performing the decryption or encryption, or that is accessing the key per se.
I think I didn't quite understand
Okay,
your
so
um
analogy. So
let me
when
explain your analogy. What you told me was that um when they get the file and it's unreadable, that the person will use his own GPG to create a key to read it,
no,
right?
that's not what I said. He's not
Oh,
creating a key.
okay. It's the same key.
It's the key you gave him. So I
Okay.
think so. Let's go back. See, guys, let's go back to the beginning, the core of what we're trying to achieve. What's the objective of encryption? The objective of encryption is to ensure that no other person is able to have access to a certain file or a certain information unless you have given them the permission. Now, one of the ways to achieve that is to first of all encrypt that information. So what you do is you would make that information unaccessible or ununderstandable for the whole world. Do you understand me? Give that file to that person and say, oh, take, this is for you. Take this. Once you give it to the person takes it. But then you would also give the person a key that would allow the person to be able to read that file. So only you and the person would actually have access or would be able to actually get access to the contents of that file.
Okay, but how come the file is unreadable when you have the key to read it?
You're not getting it. You made it unreadable so that nobody in the world will get it. The idea is, what are we trying to achieve? Let's go, as I said, let's go to the core. What we are trying to achieve is only you and the person you need to read it can read it. Now, if you make it readable, if, for example, I make this file readable and I drop it on the table and I go out, someone can pass, open it, and read through it. You understand
for
my point?
confidentiality,
For confidentiality reasons. So you would make it unreadable and you will now give it to the person you want to give it to. Then you now give that person the key to read it.
Read it. Okay.
That's
So
what we're
the
trying to
person does
achieve.
not need to the person does not need to use his own GPG.
No, so the person will still use. So now this is where, now that's the confusion I'm also seeing. GPG is a tool for encryption and decryption. It is a tool. So, for example, I give the person the key. How will the person use the key? The person will use something. The person will use the key inside a tool. So GPG is the tool that allows you to encrypt and decrypt depending on the key you have been given.
Oh, I see. Okay.
Do you see it now?
Yes.
Yeah. So the person doesn't need to create another key. The person will use GPG, no doubt, but the person is not creating another key. The person will use the key given to him, use it on GPG, and decrypt the file, which is what I want to take us through now. That's what I'm trying to take us through now. So now in this scenario, this machine is the person. This person is the machine. He was given pub-key.gpg, which is the key, and was given the file text.gpg, which is the encrypted file. He doesn't have the decrypted file. I need to retest the GPG. So me as a person, I have now gone ahead to to import that key that was given to me, which is this command I did here, this import command here. I'm importing the key into my own GPG, into my own user ID. You understand my point? Now, once I have imported this key, the next thing I will do is I will now decrypt the file. You understand me? So now let's decrypt that file.
I understand you, and I understand that the only GPG the person can use is the Kali Linux.
So GPG, so far, I want us to understand it from Kali Linux point of view. I've not installed it on Mac OS before or Windows before. It's best to understand it from the Kali Linux point of view. All right?
Okay.
So
okay, thank you. I understand it now.
Exactly. So if we come and let's create the file. So we are doing gpg-output -r, the user ID we are using to do the decryption. That is, this is the user ID that we believe has the key imported into it. All right. Then -- decrypt the file. Decrypt. Yeah. The file, which is tst.gpg. If you press enter, I will ask for the password. Please enter the passphrase to unlock open PGP secret key. The passphrase for my user ID. And I have decrypted it. Now, if I type ls, I should see a file named test.txt. Now let me see if the test.txt, let me see if the test.txt file, can you see it? Can you guys see this? So what happened is I received a key called popkey.gpg. I received a file, an encrypted file called test.gpg. I imported the popkey.gpg into my own what's it called? Into my own what's it called? Uh, into my own GPG environment with my own user ID. You understand me? So I should have created a user ID. All right. So I imported it into my own GPG environment to my own user ID. After importing it, all right, I would then use my user ID to decrypt that file. In fact, that is what would be our assignment. Our assignment is I would send the key and the encrypted file that I sent to myself. I'll send it to your emails. What I want you guys to do is download it on your Linux. For those that have our Linux already installed, download it on your Linux and then try to use the key to decrypt that file. That's our job. That's our assignment. We're going to try to use the key to decrypt that file. So meaning that we have to first of all create a user ID on GPG. We're going to have to create a user ID on GPG. Don't forget that. We would have to create a user ID on GPG. Very important. Do you get it? So do we have, I know I got a lot of confusion, but I want to believe that we're able to trash and clarify some of these things. Joe and Collins, I didn't hear anything from you guys. Are you guys fine?
I'm not fine with the
Yeah,
assignment too.
I'm fine, but I'm working, so I cannot see what you're doing. But if I go home, I'll watch the video and
Oh,
I'll,
okay.
yeah.
All right. That's understandable. That's fine. Claire, you said you're not fine with the assignment. Why? Okay,
It's just that
I remember your
it's
Linux is not ready.
yeah, my Linux is not ready, and also the command that I'm going to do I need to the command I'll create to decrypt and
I will share the
the key
command.
and all that.
I will share the
Oh, you're going
command.
to share the command?
Yes, I will share the
Ah,
command, but I also like you guys to apply yourselves. I actually
ah,
like you to apply yourselves. I'm being very honest. I'll share the command, but I actually prefer if you try it yourself. Because what if I share the command and it doesn't work? Then you now start coming and say, Kevin, hi, it didn't work. I would not be going back and forth. I think if you tried yourself and it didn't work, you would keep finding a way to make it work instead of it saying it came from Kevin and Kevin will start looking for a solution for you, right? So as I said, I'd actually prefer you guys if you watch this video again, you can, if you calm down, pause around here because it's going to be recorded. So if you watch this video again, you'll be able to see the command I just used. It's better that way because I've used it. It's actually here on this. Is right here. You just have to watch the video, the recording of this class, and you'll be fine. You get.
you should share this command first, then give us another one to work on.
No, so the command doesn't change. It's not about I want you to use. So I don't want you to even encrypt a file. You don't go through the process of encrypting. Don't encrypt. Just decrypt a file that I give you. Decrypt the encrypted file I've given to you. That's the assignment. Decrypt the encrypted file I've given to you. I'll give you a key. I'll give you an encrypted file. Go and decrypt it. That's the assignment. It's actually so it is half the job, really. Half the job. All right. So yeah, that is where we would stop for today. I would share the files and all to you guys via email. I think I have your emails on the meeting invite, so I'll share it to everyone. So you import it into your Linux, and then you try it, please. Okay. So I guess that brings me to the end of today's class. In the absence of no other corrections uh, or no other questions, um, I think this brings me to the end of today's session, today's class. Um, please don't be scared about it. We are meant to go. This is actually our last conversation relating to cryptography, so we're going to application security next. So don't be worried or scared about it. I've still not heard anybody come to me about questions regarding the projects and the assignments and all those things and the tests, or sorry, and the quizzes, the projects, the quizzes. Nobody has come to me asking further questions. So I want to believe you're fine. But I've always told you, if you have any confusions, reach out to me on Slack. I think I've responded to a few people already. You can always reach out to me on Slack and whatnot. Right?
Hello.
Yes, Adani or Collins.
Okay, maybe I'll reach on to you on Slack because I've been telling them on Slack I can't really put it together. I tried to get the learning pathway just day before yesterday.
Mm.
That
That's
I'm going to start
is it the
downloading.
project? Is it the project?
I don't even know which one we're talking about right now. So, but I got to the learning pathway when I
Okay.
saw how they now downloaded it. Then when we were talking, because the lady I was talking with was wasting so much time. So when I send that message, she takes some time before she comes back. So me to have also left that place because I have other things I'm doing at the same time. So the last we did, she said I should check that learning pathway. I got to the learning path, I saw some videos. So I don't know. I'll be watching the videos. I asked her a question. If I'm watching the videos and the site I was on, where I saw that app.slack.com, something like that client. That's where I come to this for this meeting. That's where I come this meeting from.
So
And then this
Slack,
part, this other one.
so Slack is for passing information. The learning pathway is meant to be some recommended learnings that you should try. That's what it's meant
Okay,
to
those are
be.
the ones I try.
No, as in recommended learnings that you should do. So you should read up on it, watch the videos, read the documents, whatever recommended
Okay.
learning is there. It's to help give you much more complete knowledge. Just things you can read to actually give you more information and give you better understanding.
Oh,
Do you understand?
okay.
And
And
then you
then
would also see the slides that you can look through.
okay, is that where you also see the what they call it, the assignments?
I believe
Because I was
so.
asking for the assignment. Where is it?
I believe so. I believe
Huh?
so. Yes. Yes, that's where you
Because
should see it.
Yeah.
okay. So
There's
maybe why
videos on visualization, and the last part is a quiz, which is
Exactly.
timed.
yes, I've seen that one. I did one of the quiz.
Okay.
So, but I was thinking I'll see something like the assignment or something. I've not finished looking at
The
the videos.
quiz is the assignment actually. The quizzes are the
Oh,
assignment.
the
So yes, so the ones that I'm talking about is what they call it projects, where you would like that one is like more practical assignment where you are given some instructions on how to do some things and you have to go and do it on your own with some instructions.
Sorry, sorry. That's
Yes.
No, Kevin, there's
no
no
instruction.
instruction. They want us
Oh,
Exactly.
to
really?
create like a visual machine, and you
Yeah.
explain how you did it.
Oh, really? There was
Yeah.
no step-by-step instruction?
Yes, yes.
No.
Oh, wow.
And
That that's that's
again,
that's
and
good.
again, the submission of the project is just like a share. It's taking you to social media. It's not like a repository where we can drop, I don't know, or a link. So I don't know. Maybe my learning paths have not been updated. I'm
Hmm.
just talking from my own experience. I've watched all the videos. I've done the quizzes, but trying to the project part is not so clear for me.
Okay, this is what you do. You can reach out to me on Slack. Send me a screenshot of what you're seeing on the project.
Okay, no problem.
Yes, so I'll look into it from my own end.
So sorry, if we're looking for you on Slack, where do we check?
I don't know what my name is on Slack, but look for Kevin. Let me look for my name on Slack. Let me look for my name on Slack.
I've just started Kevin on the search or something.
I want to find out my name, like what I used to like what you can use to find me on the Slack on Dari.io. Coming, looking at
Okay.
it. Uh,
That's Kevin.
okay, it's Kevin. Yeah, it's Kevin. It's
Kevin
Kevin.
and yeah.
Yes,
Okay.
yes, it's Kevin.
Right.
Just
Say hello.
send me a message.
I've done that.
All right. All right. Yes, I just saw it. I just saw it. Okay, so just send a picture of what you're currently seeing. Send to me on Slack. I'll follow up from there. All right.
Thank you very much.
All right. Thank you. I'm just seeing something from Joe. Joe, is that you? Just seeing it on the Slack. I didn't get this notification earlier. I'm seeing a message from
Yeah,
Joe.
I was having a problem trying to create the hashing file. Yeah,
Oh,
so yeah.
you're still having the problem? You
No,
might.
that's what I said. I forgot my password for my Kali
Oh,
Linux.
Kali. Oh,
So
yeah, yeah, yeah. Ouch, ouch, ouch.
I'll try it again, and if I do, I'll send you a message.
All right,
Yeah.
all right. That's great. That's all right.
Okay.
All right then. Okay, guys. Thank you so much. I really enjoy our classes together. You guys are very interactive and quite awesome. All right. Thank you, guys. Thank you for the time. Enjoy the rest of your weekend.
You
All right.
too.
All right. Thanks.
Bye
You
bye.
too. Thank you.
Thank you.
All right. Bye,
Thank
guys.
you.